wait, no best friend. Hey, wait. What's up, team? We are back. We are back. Came back with more jacks, and this time Palace coding. So Palace is like the low-level compiler version of jacks. But first, we are going to start working on a project that I've been working on for a little bit here. Let's see. So it's a little application of all the stuff that we've been learning so far with roof lines and such. So if you go to my GitHub here, Wesley Jacob Gilbert, you'll find Intel Arc GPU benchmarks. So basically what this is I just ordered a computer that has an Intel, let's see, where did I put it? It's got an Intel Core i9 processor, and it's got an Arc Pro B70 GPU. Let's look up an image. Arc B70 GPU. Let's see. So this is kind of what it looks like, but let's see if there's like a website or something Intel put out. This maybe? Yeah, I don't know if this gives y'all much information, but anyway, long story short, I'm building an HPC cluster, so that's node 1. It's got 32 gigabytes of VRAM, so enough to run some LLMs, as you can see here. But the big thing is, I just ordered all the parts for a new node. It's going to be a Xeon processor, so going a little bit more heavy duty on the CPU side, and then also it's going to be 4, not 3 to 4, although I only have 3 right now actually, now that I think about it. It's going to be 4 Arc B580 GPU cards, so let's look up that, Arc B580. So notice this card came out in Q1 of 2026, and then these Arc B580s came out, I think, December of 2024. So this is what the Arc looks like, I guess. Oh, well, can't really see it now. Man, it's kind of brutal. It was not full screen. So there it is. It was like $249 for consumers. I think it was $200 for me in the Intel Employee Purchase Program. And then let's see if we can look at some specs here. Yeah, so very similar to the thing that we just saw, the B70, but this one was in Q4 of 24, so it's like a year old, maybe a year and a half old, but it's super cheap. So I'm thinking I can get similar VRAM numbers to the NVIDIA 5090 for like half the price, although obviously expends way more PCIe slots, or I guess motherboard slots, but yeah, price per gigabyte of VRAM, it's way better for this. It also allows me to do this cool GitHub repo here. So one thing I noticed is that there's not really many benchmarks for machine learning, especially inference for Intel GPUs. They're not really adapted or adopted that much by the industry. So I wanted to apply my new learnings from the How to Scale Your Model book. Let me pull up that book again. How to Scale Your Model. So let's go to the first section. If y'all remember from, I think, 2 videos ago, or maybe last section, all about roof lines. So remember, we were calculating all these arithmetic intensities and such, talking about flops, bandwidth, etc. This is the big one right here, arithmetic intensity. What I really want to see and look at is some of these equations for Intel GPUs. And even in this training book, they really only talk about NVIDIA GPUs or TPUs. I mean, TPUs are the main thing, obviously. But like, you know, here, talking about how TPUs wired together to form clusters. Let's see, do they talk about NVIDIA GPUs at all? I know here they talk about GPUs. How to think about GPUs. What is a GPU? H100, B200, so talking about NVIDIA. Does they say anything else about NVIDIA? Yeah, NVIDIA, you know. Everything CUDA, so everything's NVIDIA based. So I think a cool little roadmap for me would be to do all the exercises that Vlad Feinberg talked about in How to Get a Job at a Frontier Lab. So if you all remember this blog, it's kind of the whole motivation for this whole series, how to get a job at a Frontier AI lab. Practical next steps, get familiar with Reiner analysis, go through the JAX tutorials, read and do every exercise of the scaling book. That's this book right here. And then do some exercises like code a 10 million transformer using JAX, Flax, and Optax, and Colab, drive chinchilla laws, work on the MOE layer and kernels, record yourself doing it, and send it to them. So I want to do all this, basically everything that requires actual compute on TPUs, just because this whole thing is based off of TPUs. What does it say? T4 GPU. But I'm going to do it on TPUs. I'm going to rent it on the Google Cloud. Oh, whoops. I'm going to rent it on the Google Cloud, and then I'm going to go in here and do some more stuff with the Intel GPUs. But in the meantime, since I'm already kind of on this Intel GPU thing, and I think I need a little break from this this thing to recharge, I guess, my interest. Like, I don't know. I don't even remember where we were anyway. But long story short, I want to work on this benchmarks thing here a little bit first. That's what we're going to do today. And maybe I'll do some of these if there's actual code. Maybe I'll do some of these on my computer. But let's see, where were we last time? Last time we left off around a question that said hard or something. It's pop quiz. No, that's an appendix. Pulling it all together hard. Yeah, we were doing question 6. So maybe we'll also get to question 6 today. What I'm planning to do is some Intel stuff, and then get back to this. Maybe do some questions for sharded matmuls. But without further ado, let's get into it. So first, I want to connect to my node 1 here. So let's do that. So I'm connecting over Tailscale. Tailscale status. Oh yeah. Wait, did I take that in? Yeah. So this is the guy that I want right here. W Gilbert node Linux. So my SSH into that. SSH W Gilbert at W Gilbert node. So yes. Type in my password. Cool, we're in. So the next thing I want to show y'all on GitHub is I started working on a TUI terminal user interface called ArcBench. So another thing I noticed was that there's not really an easy way to set up benchmarking stuff on Intel, because there's not really much support for machine learning stuff on Intel. So what I want to do is make basically something that you can pip install, where you can run it and it just like shows like a user interface to run benchmarks. So what I'm going to do is pip x install ArcBench. Oh yeah, I didn't submit it to PyPy yet. So instead, I'm going to, actually on this computer it already exists. So let's see, ls, we want to go to ArcBench. Okay, so cd ArcBench. Cool, we're in. Now let's see all the files. There we go. So we got our stuff there. Now what I want to do is actually run it. So I think I can just pip install e. Oh. What? Maybe I was using UV before. I think I was doing UV pip install e. No. Well, let's see what happens if I say just ArcBench. Man, not found, of course.
I haven't talked to my kids in a long time.
Maybe I gotta edit this stuff here.
They had to let go before I did.
When
you're in it, drugs, alcohol, you keep telling yourself that you'll fix things later. I've missed birthdays, holidays.
Let me turn off the
I came to Renew Health because I didn't want my story to end there.
TV in the meantime.
The first time.
All right, we're back. Got some oatmeal now. Oatmeal with honey. So where were we? Getting ArcBench to work. Yes, that is what it was. So pip install ArcBench didn't work. I have the files there though. I'm trying to remember, how did I start my TUI? Oh, I packaged it. So I made a TUI at work as well. But I packaged that one with, I packaged it into an executable. So how do I run it locally though? Oh, on VS Code. So maybe I just hit run on a file. No, I don't remember because that was so long ago. All I ever do now is the executable and rebuild every time I make changes. So it says pip is not found. Oh, do I need to activate a VM? I wonder. So when I hit ls ArcBench works for our project, I don't think there is a VM here. Yeah, you're supposed to run app.py, that's how it works again. So I was working on my laptop earlier to SSH in here and do this development. But okay, so pipx didn't work. What about pip? No, so pip itself didn't work either. When did I try pipx? Let's try pipx again. Pipx. Oh. Pipx install ArcBench. UV pipx install ArcBench. Okay, yeah, UV pip install ArcBench. Checked one package. Oh, brother. UV pip install E. Am I even using UV? how do I know if I'm using UV? I could go to my laptop and figure it out. But obviously I gotta change these. Well, oh, E dot. Maybe that was what I was doing wrong. UV pip install hyphen E dot. Oh, embarrassing. All right. Now let's do Archbench. Oh my lord. Spelled it right. So how was command not found? Well, let's check out main. So Archbench should be in screens. Where would it even be? Shouldn't app.py be out here? Yeah, it should. So did that get deleted or something? Okay, so Archbench. Oh, there it is, yeah. Okay, textual. Maybe you have to say like Python run. Python run app.py. No Python command found. Python 3 run app.py. No such file directory. Well, let's dig into this bad boy then. So ls. Okay, so we got Archbench. Let's cd into Archbench. Let's see what's in here. So I see app.py. Nano app.py. Okay, so yeah, so everything that's supposed to be here is here. Just one annoying thing about Nano is you can't scroll. Okay, so exit. I could ask an LLM like a perplexity session that was helping me to figure it out, but for learning's sake, I want to know why it's not working. So first of all, I wonder what area of code allows me to just say Archbench, which was supposed to make it run. There's definitely not benchmarks. Data, no. I don't think so. Telemetry, no. Benchmark, no. Textual app entry point. Yeah, it should be in that main app.py thing. So let's read this. Okay, so textual import app, compose result, binding, so import the screens. So I don't really care about the CSS. bindings, sure. Don't care, don't care. On mount, none. Define main. App equals arcbench app. App.run. So I just do this. I might need an LLM to come in here and figure this out. If I just do regular pip install, I mean, I don't think I have actual pip install on here yet. uv pip install e. Yeah, there needs to be a VM. I don't see any VM bin here. .vm source bin activate. Is that how you do it on Linux? I'm gonna get my laptop. Never mind, my laptop's in my car, so I'm gonna ask Perplexity. So let's get it. Parent folder. Ah, shoot. Dark bench. And then uv VM. No. So it already exists. So, oh, this is how you say it in Linux. Source vm /bin /activate. And now we can just say arcbench. Well, I already pip installed outside of the VM, so that's not a problem. But I can figure that out later. All right, here we are. This is arcbench. Let's move this over so you can see it better. And actually, let's do this. Sure. Let's do this. And whoops. All right. So this is arcbench. So the first thing that it does is on this welcome screen here, it shows you a little ASCII art. Intel Arc GPU benchmark console for Linux. The next thing is it automatically scans your system and detects things that are necessary for these benchmarks. So one thing that's a little bit buggy right now is Intel 1 API /SQL runtime not found. I'm not sure if I actually do have that, but no, I do. I installed that, I remember. So I gotta figure out what's going on wrong with that. But so it shows you do have an Intel Arc GPU. That's obviously the most important thing. Can't do any of this without that. Llama Bench. So yeah, I have that downloaded. GPU telemetry. Sure. Model cache directory. So the reason you need GPU telemetry is so that we can actually see what's going on. The whole point of this thing is like to see your GPU workload through the process of doing the benchmark. And then model cache directory, sure. So this continue button, whoa, okay, so this is a new glitch that I haven't seen before, is all these like question marks. But anyway, so what this is supposed to show is there's supposed to be 4 buttons here. There's supposed to be a button for Llama benchmarks or machine learning benchmarks. One of these should be like 3D benchmarks, like Blender, for example. It's the one that I really want to use because you can see a big Blender guy. Then one of them should be like HPC / like scientific workloads, and then what else would there even be? Let's see. Is this the main README? Yeah, it is. Does it say? No, yeah, multi-GPU configurations? No, I don't know. Maybe there should only be 3 buttons eventually. But anyway, just because I'm developing it, I know that this top left button should be the machine learning ones. So we can figure out why the names aren't showing up later. But anyway, what you get to here is a little console where you can select what type of benchmark you want to do, and then it should run it and download the model if you don't already have it. But obviously we're getting into a little error here, so let's read this. Wow, this is really long. So there's something wrong with this. Try to insert a widget with ID. The widget already exists with that. Alright, that's easy. So where is this? Man, I wish I had VS Code. But actually, I wonder if I can get like Vim on here. That would make it easier. But for now, let's just do Nano. Nano. First of all, I think I have to go into. Let's see, where does this exist? So it's in. It's probably in that screen. That's what my guess would be. So it's probably not in the home screen. It's probably in the. It's in the running screen. No. Maybe it is the home screen. No, but we need to fix that too. Screens. Let's see. Category. This is probably it. Let's see. Pose. So, I mean, in this, can we search detail, title? Only I care about that. I think this is what I care about here. So, where was it saying detail title is wrong? Fine. On button pressed. No, so that's not it. See, the nice thing about LLMs is I could just put this whole thing into it and say, hey, fix this, and it would know super easily what we're looking at, but let's see. Try to insert a widget with ID detail title, but a widget already exists. That all child widgets have a unique ID. I'm guessing it's here. See, the thing is, if you change one, that's good enough. So anyway, to build detail widgets, not selected, select the benchmark to see details. If it's in VRAM, mode. See, the problem is this isn't so simple, is it? Because this gives a detailed title to every, like, across multiple things, doesn't it? And we can try. Let's see what happens when we change that. So cd arcbench screens, and then just check that's there. It is nano category.py. And we want to go down to and build detail widgets. me this is already kind of red here. I probably could insert like one of these things, like, you know, P label. Let's try that and see what happens, because that should make something unique for each one. P dot label. It's a little bit of a messy way to do it, but whatever. All right, we're save. I guess I could just hit exit and it should ask me if I want to save. Yes. Yep. Cool. Now let's try it again. So cd bang bang. Cd. Oh shit. Cd bang. What? Oh, that's why. Let's try our Archbench. So still we have that problem with the buttons, but we didn't really try to fix that. So also still not finding this. That's all good. Or maybe I just need to wait a little bit longer. Still scanning system. No, it's probably just a static thing. It's not changing. All right. So again, I know that this is the top left button. Uh-oh. It's not begin with a number. Well, let's try a new thing then. CD, Archbench, screens.
You'll need to unlock your iPhone first.
What? Oh, Siri thinks I was talking to her. CD, Archbench, screens, category, .py. Oh, whoops. Let's just do this and get rid of that. And then nano category.py. Let's see here. Maybe I could also put something like model file name, because that should be something unique. Let's try it. Model dot file name. Let's see if that works. Yes. Sure. Let's try this again. CD bang bang. Oh, whoops. CD bang bang. CD bang bang. Then Archbench. Okay, I already know I have this stuff, so I'll skip that. Uh-oh. Alright, yeah, at this point, I'm just gonna load it into Perplexity. Or not. I'm just going to switch what I'm going to do. So on Perplexity at the bottom here, I wanted Perplexity to write a submission to the Llama CPP SQL discussion about the benchmarks that I've been doing, but it found there's a new version of the 8-bit quantization of the Llama model that I was running. So let's run that first, the manual way rather than using Archbench. And then I'm gonna ask Perplexity to submit this, and then we're just gonna get back to Jax. All right. So. Let's make these a little bit more even. Uh-oh. Let's see. Maybe that's better. Nope. Anyway. What's the center here? Got. Alright. So She's a smooth operator. Alright, let's see what perplexity says here. Yeah. I'm also going to say, also update the README with better install instructions. I was struggling on my desktop. SSH session. Mention the ability to use UV or like UV pip as well, or mention the VM requirement or something. I couldn't use Arcbench after UV pip installing outside the VM. Did that by accident, but it worked when I activated the VM. Maybe this is pure user error, but if it is possible to be super clear to others, is it possible to improve clarity without holding hands? Maybe we should do that. Alright, before I say that, let's read this. Okay, so what was fixed? Duplicate changes, commit, duplicate ID bug, yep. Okay, so that should be fixed. Q8 preset. Added R3 to the arg so get through repetitions. Stable postfix mean. Cool. I don't want to run it manually right now. I'm going to try it on the Arcbench. But I'm going to leave that there just in case. I'm not going to submit this so I can do both and see what happens. So first, git pull. What? Oh, stash them. Git stash. Just hit all. Oh Lord. I don't know how to stash things. Okay, well, now git pull. Bruh. Git pull. There we go. Arcbench. Let's wait and see if it can detect everything. No, it can't, so that's fine. Go up here. So another thing is, these fit in VRAM, but these words don't fit in VRAM, so I'm gonna have to make this a little bit further out. It can't just be a standard 2-column thing, or it's gonna be a scroll bar. But anyway, I think this is what I was working with, right? 8-bit quantization. Incredible. So I hit run benchmark and nothing is happening. Maybe it's running in the background, but I think it was supposed to take me to a new screen. I'm gonna wait a little bit just to see if it shows the results at the end. Yeah, at this point, I'm convinced it's not running. If I double click it, no. Well, in that case, let's get out of here. Q. Uh-oh. Escape. Oh no, is it stuck? I might have to nuke this. Alright. That's unfortunate. SSH, W Gilbert, node. Oh, whoops. Not W Gilbert node. Should work, right? Yep. All right. CD, workbench, and then actually no, I don't have to be in here. What I want to be in is llama, the manual stuff, and then yep, and git pool. What? Why do I need to? Is there even any git established in this? I don't think there is. Oh, okay. I guess there is. Alright, wow. That's a lot of stuff. Well, let's do this. CMake, build, config release. Dude, what? Copy. Paste. Why is that not working? Oh, shoot. But if I hit this, it'll work, right? No, it won't. Okay. Alright, let's just type it manually. CMake, build, config, release, J, money sign, and proc. Open SSL not found. Yeah. Alright. Wonder why this one's so much more complicated than the other benchmarks I've done manually. Must be because it's a pull request or something. Error 2. Well, I don't know what that is, but I'm gonna try this again to see if it works. If not, oh Lord, I forgot this isn't working. So, oh shoot. Source, optional, Intel, one API, set variables .sh. Alright, okay. I typed this whole thing out by itself too. Build bin llama bench. Oh, actually, I don't need that. M llama dot cpp slash models slash meta llama 3.1 8b hyphen instruct hyphen q8.0 q8 underscore 0 dot gguf, and then ngl 999 hyphen p 512 hyphen n 128 hyphen r 3 hyphen o JSON L. What's the point of JSON? Uh-oh. Alright, well. Also, I got an error in the manual command to run the new version of Q8 model. Let's paste that in here. No need to ask, she's a smooth operator. It's from the old build. It's the actual error with that line. Model path. Yo. I wonder why it won't let me copy and paste. It's the terminal. That is super annoying. But since we're doing a lot of plumbing here, what I'm going to do is take a quick break, and then we are just going to go back to how to scale your model. It's probably more interesting for the viewers anyway than watching me just read LLM output, do all this plumbing. So, whoa, that's a lot of different models. Link your command field with Xcode 1. Cool. Well, I'll see you in about 5 to 10 minutes. Alright, I'm back, but I'm realizing now that my notepad is in my car. So instead of doing these, what we're going to do is go back to Jax. Ducks. And we are going to try to get Jax running on this node here. Wow, I'm shocked that it is still connected. But long story short, let's see what we can do. Jax is experimental for, it's only experimental for Intel GPUs. But let's see what we can do. Yeah, look, they don't even have an option for installation for Intel GPUs. But it does say down here, experimental. So see, the main things it runs on is AMD on Linux, Google Cloud on Linux, NVIDIA GPUs on Linux, and then CPUs for everything. Anyway, let's see what we can do for this Intel GPU here. So first, do they even have a section dedicated to that? Intel GPU. Intel provides an experimental One API plugin, the Intel extension for OpenXLA for Intel GPU hardware. More details for one of the following tutorial methods. Let's do it. Maybe we can report an issue to the JAX issue tracker too if we have any. So let's move this bad boy over here. Sure, that'll work. And scroll up so you can see. And let's get started with JAX acceleration on Intel GPUs. Oh, interesting. Okay. Intel extension for OpenXLA plugin. So extension for OpenXLA includes PJRT plugin implementation, which seamlessly runs JAX models on Intel GPU. The PJRT API simplifies the integration, enabling the Intel GPU plugin to be developed separately, allowing smooth integration with JAX. This same PJRT implementation also enables Intel GPU support for TensorFlow and PyTorch. Nice. I don't need more details right now. Required section. Bruh. I'll check that after this. Let's read this first. Following table tracks Intel extension for OpenXLA versions and compatible versions of JAX and JAX-lib. The compatibility between JAX and JAX-lib is maintained through JAX. The version restriction will be relaxed over time as the plugin API matures. Intel extension for OpenXLA. Sounds good. Conda is recommended as the virtual running environment. Gotcha. So I don't have Conda right now, but Conda create. Okay. Cool, and then we got test that. Reference results. Example, run stable diffusion inference. So let's not look at the example yet. Expected result, support. All right, let's just get through this basic preview and then we can get into it. So let's see. So I'm curious what these look like. Gotcha. Preview. All right, so let's look at the requirements in a new tab. Oh, there's an actual README here. This is just the regular OpenXLA project. Let's read it anyway. OpenXLA project brings together developers, implementation. Separately allowing smooth integration with JAX. Same PJRT implementation also enables initial Intel GPU support. Yeah, we already read that. Alright, so this is going to be, seems like a long kind of thing. So in that case, I'm just going to skim. Let's see. So Ubuntu. So we have a higher version of Ubuntu, but sure, that'll be fine. So the requirements. Data center GPU series. Uh-oh. Yes, it doesn't really look like it works for my GPU. So let's do a little bit of plumbing. First, let's just do the basics. Let's see if we can get it on my GPU. Following table tracks Intel extension for OpenXLA versions and compatible versions of JAX and JAX-lib. The compatibility between JAX and JAX-lib is maintained through JAX. This version restriction will be relaxed over time as the plugin API matures. Gotcha. So first, let's install Conda. So let's go here. Installing Conda. Oh, I'd rather do mini Conda. $400 megabytes. It's a lot. Well, let's do it. Linux. Download the installer and your terminal run. The installation and the Conda distribution that comes. Conda Python packages, a small number of useful packages. See more packages use the Conda install command to install Thousands of packages available by default. Let's watch this. It's only a minute.
One of the first decisions you'll need to make on your data literacy journey is whether you should install Anaconda Distribution or Miniconda. Think of Anaconda Distribution like a store-bought laptop, assembled and ready to go right out of the box. If you're new to data science, this is probably the right choice for you. The Anaconda Distribution installer comes stocked with everything you need: Conda, the command line package manager; Anaconda Navigator, the desktop GUI for launching applications and managing packages, environments, and channels; the latest version of Python supported by Anaconda Distribution; and over 300 curated packages for data science and machine learning. Miniconda, on the other hand, is like a computer built from scratch. You can optimize your experience to be exactly what you want, but it requires more experience to make it all work correctly. The Miniconda installer only includes Conda and its dependencies, one of which is Python, making it about 10 times smaller than the Anaconda Distribution installer. Once you've installed Miniconda, install only the packages you need. Download the version of Miniconda that's right for you from our Miniconda installation documentation. To install Anaconda Distribution, check out our install videos or consult our installation documentation.
Alright, you know what? I'm just gonna install actual Anaconda because I have 4 terabytes of memory right now on this thing, and I'm planning to even buy more, so might as well just install Anaconda. Packages in one step, just over 50 minutes. Oh, and then I'll get Jupyter too, and in which case I could probably, instead of having to use Nano, just like open a browser that I can see somewhere else, like on some other computer, since I don't think Ubuntu server distribution has native browser server support, but whatever. All right, let's see. Maybe it does. I don't know. Alright, could it get started, or... Oh wow, it installs all of that for you already. It's cool. Well, let's get started. Sign up with GitHub. Sure. Go to my Gmail. Oops. I have to say company. I guess I'll say yeah, I'd say I'm more of a student. Actually, I'm gonna say developer. See, the problem here is I'm gonna say everything. So I don't want to install this on my desktop because I'm pretty sure I already have it. Yeah. How do I? Oh. Oops. No, I don't want the Windows graphical installer. Command line instructions. How do I do this for Linux? Okay, let's watch this.
Hello. In this video, we'll be installing the Anaconda distribution on a Linux machine running Ubuntu with an AArch64 architecture. Start by downloading the latest version of Anaconda distribution by opening a terminal and running the wget command for your Linux architecture. Then, install the distribution by running the bash command for your architecture. Press Enter to review Anaconda's terms of service, then press and hold Enter to scroll. Type Yes and press Enter to agree to the terms of service. Press Enter to accept the default install location, or enter another file path to specify an alternate installation directory. The installation might take a few minutes to complete. When presented with the option to initialize Conda whenever you open a new shell and to recognize Conda commands automatically, enter Yes. If you choose not to, you can always initialize manually by following the manual shell installation instructions in our installation documentation. The installer finishes and thanks you for installing. Close and reopen your terminal window for the installation to fully take effect, or refresh the terminal with the appropriate command for your shell. You should see base appear. This tells you that you're in your base Conda environment. Try running a Conda command, such as conda list, which displays a list of packages installed in your active environment and their versions. Great! You've successfully installed Anaconda. Happy coding!
So I think Ubuntu is AArch64. So use wget. And this should say Ubuntu or something, right? Or maybe that works in itself. I mean, I thought the video said that you want the wget command for your specific architecture, right? Oh no, I mean, this wget command just said that exact thing. Let's try it. You might mess up, but the nice thing about AI is you could probably fix it. Oh, first I also want to do this. Oh Lord, no, it won't let me copy and paste. Oh, thank God. Alright, it looks like it's working. Alright, so now it's downloaded. Let's install. So, let's see if this works. Please, please work, please work. Yes. I don't know what's going on here. I like right clicked and then I left click over here. Whatever. I know the agreement. Yes. Maybe there should be another location, right? In the optional. Can I back out of this? All right, let's see. Intel models. What? Let's install it in that place. Let's do that. Oh, brother. All right, CD. I just downloaded it right in the middle of it. Actually, let's remove it. Or wait, can I move it? How do you do the move command again? How to move a file in Ubuntu terminal. Ah, there we go. Okay, so file name. So Anaconda 3 2025.12.2 Linux x86 score 64.sh, and then say opt environments. Let's go, baby. All right, let's change directory. Opt ls cd environments ls. Oh, whoops, ls. Cool, we got it. All right, now we want to run this, right? Yes. It's gonna install it. No, that's not where I want to install it. What? Oh, I have to do this. Did I type out the 3? Let's just use this Google thing here. Trying to install Anaconda in an opt location on my Linux Ubuntu 26 computer terminal. Here's my terminal. What is wrong? How do I install in the opt environments, dear? Dun, dun, dun. I woke up for the morning. So I have to install again. Oh no. So first of all, let's do this. My lord, why is it? Okay, well, whatever. So I have to say this. Wait, what? Oh yeah. Is it just because I have to do sudo? Oh, root Anaconda 3. No, I want to do this. Okay. That should work, right? All right, we did it. Let's go. Wait, maybe I should have installed it at the root. Well, whatever. It's there now. Actually, let's ask Gemini. Okay, so this is right. Well, let's do this first of all, and then so let's get out of here first. So how do we end our SSH session? Exit. And then let's do it again. Then let's do these things I was talking about. And then let's do this. Whoops. Schedule XC. Cool. So already finished, so hopefully this will work. Uh-oh. Oh, that's why. We need to actually give it a real name. Environments 3. Cool, and then do the same thing here. Copy, paste. Environments 3. Oh, bruh, you couldn't see anything I just did. Whoops. Well, whatever. Well. Oh, yeah. All right, and then environments. What? Oh, what the heck? Did it not run right? Oh, okay. Well, that should be it. Alright, so I promised a friend I would meet him at 2 o'clock to watch the USA World Cup games, so I'm going to go do that, and then I'm going to come back. We can work on getting Jax installed here, and then maybe run a couple of the documentation exercises on my Intel GPU, see if it works at all. Until then, catch y'all later. Until next time, bye-bye.